In the past few years, our country has witnessed a remarkable growth in the number and size of construction projects for economic development of the country. These projects include power plants, irrigation works, and other public services. The effective use of resource materials like coarse aggregates, fine aggregates, water and cement is of paramount importance as these involve large sums of money. A few years ago, when concrete technology was not understood well by engineers, technicians and contractors, cement concrete was being used as a simple construction material without exercising scientific principles for its quality control. Different ingredients like cement, fine aggregates, coarse aggregates, and water were mixed in an ad hoc manner without knowing and predicting the accurate behavior of concrete so obtained. Cement forms one of the most important ingredients of concrete mix in terms of its cost and behavior. In order to make quality of construction better, it becomes necessary to study the behavior of cement through various laboratory tests. To assess the quality of cement, the important tests conducted in the laboratory are normal consistency, initial and final setting time, soundness, compressive strength, and fineness. In this film, the determination of normal consistency and initial and final setting times shall be dealt with. Normal consistency of cement is defined as the percentage of water by weight of cement which produces a consistency which permits a plunger of 10 millimeter diameter to penetrate up to a depth of 5 to 7 millimeters above the bottom of Weichert mold. Weichert's apparatus, fitted with 10 millimeter diameter plunger, is used to perform normal consistency test. This test involves a number of steps. Take 400 grams of cement and place it in an enamel tray. Adjust the indicator of the Weichert mold to show the zero reading when it touches the surface of the non-porous plate below. Measure 25% of clean water by weight of cement. Start the stopwatch the moment water is added. Thoroughly mix it with 400 grams of cement sample. Fill the Vicats mold placed on non-porous glass plate with prepared paste. Shake the mold to expel out any entrapped air and level its surface with the help of a trowel. Place the prepared mold under the plunger. Unscrew the clamp to bring the plunger just in contact with the surface of the paste and quickly release to allow it to sink. Note down its penetration reading from the bottom. In case a reading from the bottom is more than 5 to 7 millimeters, increase the water content. If a reading is less, reduce the water content. The operations of mixing, filling, leveling, and testing of the sample should be repeated till 5 to 7 millimeter penetration is obtained. The entire operation of mixing, filling of the mold, including testing, should be completed within 3 to 5 minutes of adding water to the sample. Normal consistency of cement is equal to weight of water divided by weight of cement multiplied by 100. Express this amount of water, which is 26% in this case, by weight of dry cement. Normal consistency is equal to 104 divided by 400 multiplied by 100, which is equal to 26%. No standard values for normal consistency are specified. Therefore, it is necessary to determine the consistency of cement because other tests are dependent on this normal consistency. Initial and final setting time of cement. Having determined the normal consistency of cement, let us now determine the initial and final setting times of cement. The phenomena of setting refers to the start of chemical reaction between cement and water and loss of plasticity of cement paste. Initial setting time of cement is defined as the period elapsing between the time when water is added to the cement and the time at which needle of 1 millimeter square section fails to pierce the test block to a depth of 5 to 7 millimeters from the bottom of the mold. Take 400 grams of cement and place it in the enamel tray. Measure the quantity of water at the rate of 0.85 p times the weight of cement. For example, if normal consistency P of cement is 26%, as in this case, then the quantity of water required will be 0.85 multiplied by 26 divided by 100 multiplied by 400, which is equal to 88.4 cc. Before making the paste of cement with water, fix the 1 millimeter square needle in the Weikot's apparatus. Adjust the indicator at the 0 mark when the needle just touches the glass plate. Lift the indicator and remove the mold. Mix the measured quantity of water with cement and simultaneously note down the time. Fill the Weikot's mold with the cement paste so prepared and level the surface. Place the test block under the needle. Lower the needle till it comes in contact with the surface of the test block and gently release, allowing it to penetrate into the test block and observe penetration. Repeat this step at appropriate time till the needle fails to pierce the test block 5 to 7 millimeters from the bottom of the mold, and note this time. The initial setting time of cement will then be equal to 11 a.m. minus 10:25 a.m., that is 35 minutes. 10:25 a.m. refers to the time when water was first added to the cement. Time for mixing and filling the mold, including testing, should be between 3 to 5 minutes. Final setting time is determined on the similar test block prepared for determining the initial setting time. In this test, 1 millimeter square needle is replaced by a needle with annular attachment of 5 millimeter diameter. Final setting time is defined as the period elapsing between the time when the water is added to the cement and the time at which the needle makes an impression on the test block while the attachment fails to make it. After the elapse of initial setting time, observations with annular attachment are made at appropriate time intervals till the needle makes an impression on the mold while the attachment fails to make any impression. Final setting time will then be equal to the difference between the time the moment water is added to the cement and the time at which attachment fails to make an impression. In this case, final setting time will be equal to 1:30 p.m. minus 10:25 a.m., which is equal to 185 minutes. The final setting time, therefore, indicates the complete loss of plasticity of cement paste. Importance of this property of cement is that the cement concrete or mortar should be molded in its final position before initial setting time, and no movement should be given till its final setting.